So in this case, we are going to consider another exam question, which is based on our steam turbines. We are given this from our August 2025 exam. So I'm just going to quickly consider this question, all right, with the information that we have, all right, with the information that we have, let us try to answer this. All right. We had another part of our question here, which is to find or to determine uh, from the velocity diagrams drawn in question 5.1. So let us consider 5.1 first to construct to a given scale, all right? Our scale here is 1 millimeter as to 4 meters per second. So it is equivalent to 4 meters per second. This is what we are given as of our scale. And we are asked to draw the diagrams for the turbine in the answer book. Indicate all lines as well as the magnitude of all the angles on the diagram. So we need like everything, like all lines as well as the magnitude of all angles on the what? On the diagrams. So meaning to say everything has to be indicated. All right. We are given first, there is no axial thrust. No axial thrust was developed in the first stage and second stage of the velocity compounded two-stage impulse turbine. So there is no axial thrust. And it is for what? For both the first and the second stage. We do not have the axial thrust. When we do not have the axial thrust, it affects the what? The flow velocities. Remember that. When you do not have what? The axial thrust, it follows that VF1 is equal to VF2 for the first diagram. And for the second row, VF3 is equal to VF4, which are the flow velocities. That is when there is no axial what? Thrust. So since it is affecting both stages, right? So this one is for both stages. All right, no axial thrust for both stages. So that means VF1 is equal to VF2 and VF3 is equal to VF4. That is the effect. It affects what? Flow velocities. Okay, let us move on to another part. We are then given the inlet angle of the fixed blades is what? 35. The inlet angle of the fixed blades. Remember, when you consider the fixed blades, it is this part. So what will enter, this is the part here. What we are actually referring to is the exit from the first diagram to the second diagram. What will enter? Beta 1. That is to the what? To the fixed rope. All right. So the inlet, these here will be the exit. But what will enter is from what? From the first diagram. All right. So if it is the angle, the inlet angle to the fixed blades is going to be beta 1. So that's what you must understand. That's our beta 1, which is what? 35 degrees, all right? Of which we talked about this. Remember, our beta 1 from the first diagram, that is the exit angle of steam from the first row, which is very true, but also representing what? The same thing as the inlet angle of the fixed vane, which is the fixed what? The fixed blade there on that part, all right? So that's our beta 1. So that is what we are given on that part, okay? And while the average blade velocity is, right? So our U is given 152 meters per second. The steam exits the moving blades. Take note, the moving blades, but of what? The second stage. So take note what we are dealing with. We are dealing with moving blades, but they are of what? The second what? The second stage at an angle of 30 degrees. So that's if we are to consider the moving blades but of the second what? Stage, the second diagram. This is the second moving blade. So that's the blade exit is going to be the angle phi to this one. That is the one that you're given. So we have the exit. So we are given angle what? Phi 2, the exit of the moving. These are moving blades, all right? So that's our 30 degrees to the plane of rotation, and the velocity of what? Flow, the flow velocity that we have been talking about here at the inlet to the second stage is 90 meters per second, all right? That is at the inlet of the second stage. This one, the second stage, at the inlet, VF3. But remember, VF3 and VF4, they are equal for where there is no axial thrust. So we're given the flow velocities for the second diagram, VF3, which is same as what? VF4. So that is 90 meters per second. And the velocity coefficient for all the blades is 0.96. The coefficient of friction K is given for all blades as what? 0.96. So we need to construct according to the given scale. All right, so we're just going to try to have a sketch. So from what you're given, we are going to try to produce a sketch and figure out what is it that we can work with from that given sketch. All right. So remember, from from the scale that we are given, all right, we are given our scale to 1 millimeter to represent 4 meters per second. So using that scale, our U, we're going to divide by 4. So that's going to be 152 divided by 4, which is 38 millimeters, 3.8 centimeters, all right? That's 38 millimeters. And also this one, divide by 4, it was gonna be 22.5. So this is 22.5 millimeters, all right? Just in between 22 and 23. So this one, since it is originally given, let us not round off. Let us just use as it is. We're just going to take in between 23 and what? 22 and 23. That's where you're going to take 22.5, all right? But if it was something that you are actually calculating, you can round off to the nearest whole number. But this one we are originally given. Let us just try to use as it is like this. Okay, so that is what we have. And according to the sketch, you are going to see that from the first diagram, we are actually limited. All right, what we know is that we have got the same, this part of the flow velocities. It simply means this is going to be horizontally taken from the same horizontal line. That's maybe we have got this here like this. All right. From A, B, C, D. C and D will be on the what? Same horizontal line for us to have these flow velocities being equal. All right, for us to have these flow velocities from D to E and from C to F. For us to have these flow velocities, they are what? Identical, equal. All right, so that is what you are going to need, must be horizontally given. But from the first diagram, we can see that we have, or we are given, we have got the value of what? U, this one. We have got this part of our U. We've got this. And we've got angle beta 1. Remember, this is beta 1 here. That is, we are given this. That is the only part that we have from the first diagram. So we are limited. So let's try to work out from what? From the second diagram and see how it was going to look like. From the second diagram, this is what you're going to have, A to what? To B. And remember, same concept about what? The flow velocity. So C and D will be on the same horizontal line, just like what we had on the first one. So if this is our point D, C and D must be on the same horizontal line. So let's say this is where we've got our C, from A to C like this. All right, so this is the second diagram. Okay, so from here, I want us to see something. We know that we have got this U, this one. It is the same as before, so we've got this. And we have got this from our second moving blade, the exit, the angle phi to the exit here. We've got this angle, all right? And the flow velocities, they are there from point D going to what? To E, all right? From point D to point E. From point C going to point what? To point F. We have got these flow velocities. This time we have got these. Previously, we are not given. We just know that they are the same, but we do not have. We only had what? This value of U and that value of what? Beta, this angle here, the angle what? Beta 1. That is, we are limited from the first diagram. We are limited, much limited. But from the second diagram, we can see that we can play around with this and have other values that will help us to produce what? The first diagram. So this is what we are going to do. We are going to work from the second diagram, but still on the second diagram, we can see that we have got this value of U, this angle here at B, which is our angle phi 2, the flow velocities, they are there. But we do not have this V3 for the second diagram. Remember, this will be V3 and this will be our VR4. We do not have those ones. Okay, so what we can do is to find from B to D, this one. B to D, it represents VR4. You can work out that one from triangle BED. So I want you to just do this so that you do not have a lot of things. From triangle BED. From triangle BED, find or calculate this one, BD, the length of BD, which represents what? The length of BD represents our VR4, this one. That's our VR4, relative velocity for the second diagram. All right, we are focused on the second diagram. So it was going to be like this. It's a right angle triangle from B to E to D. It's a right angle triangle that you're going to form like this. It is like this. This is where the point B is. This is our point E. This is our point D. So ED is the flow velocity. So it is at what? 90 degrees. We know that it is at what? 90 degrees, the flow velocity. So that is the one that we have here, this one. We have that one, the E to D, this one. All right, which is in millimeters, 22,5 millimeters. That's the flow velocity. So what we need is to find BD, this one, from B to D. In a right-angled triangle, having the angle here at B, that is this angle at B. We have that angle at B. The angle at B is what? Is this angle phi 2, which is what? 30 degrees. So we can find BD. We cannot use the U, this one, U, A to B. A to B is in within here. It is not at 90 degrees. That is why you need to take from B to what? From B to E, because what you need is the right angled triangle that is going to be formed. So let's calculate BD, which represents what? VR4. Okay, so that's the right angle triangle. Given this angle, we can see that the one here, the 22,5 that we are given, our VF for the flow velocity for this one, is the opposite. What we need to calculate is the what? The hypotenuse, the one that faces 90. So we can use our trigonometric ratios where there is opposite and hypotenuse. That's the ratio of a sine. So the sine of 30 degrees is equal to, remember, sine theta is opposite over hypotenuse. So opposite 22,5 in millimeters over the hypotenuse, which is our VR4. So that's it. We can find our VR4, just play around, cross multiply, then divide. So that's 22,5 millimeters over the sine of what? The sine of 30 degrees. So that's our VR4. So 22,5 divided by the sine of 30 degrees was going to give us 45 millimeters. So we have what? VR4 as well. If we can consider these calculations from that triangle, it means we also have what? VR4, which is 45 millimeters. All right. So we have this one, our VR4. This one, we have it. With the VR4, we can find VR3. Remember the relationship where there is what? The coefficient of friction. Guys, you must know this relationship between VR4 and VR3. All right, also between VR2 and what? VR1 and so on. So as we're just focusing with what? VR4 and VR3. So we can also calculate what? VR3. So it follows that VR3 is equal to simply divide by K. So that's VR4 over K. So you're going to take the VR4 that you calculated here, which is 45 millimeters, divide by what? 0.96. Okay, so that was going to give us approximately 47. So this one, since you are the one who is calculating it from the calculations not originally given like this, you can round off direct to the what? To the nearest whole number, all right? So it was going to be approximately 47 millimeters. So we have what? VR3 as well. 47 what? Millimeters. So we can see, guys, that from the second diagram, there is a lot of information given. So what we are going to do is to work out from the second diagram, or to draw from the second diagram, or to start with what? The second diagram. Okay, so this is what you're going to do. Since you know that the first diagram is on top, then the second diagram is below. So you must have enough space that you're gonna leave on top for the what? For the first diagram, since you're gonna start with the second diagram. So you leave enough space, all right? So here, I'm just gonna try and see what I can do, or I can just even move it after. Let me just do it here, then I'll just move it down afterwards, all right? So like I said, we are starting with what? The second diagram, this one. So we're gonna start, since we have U, so we're gonna construct this horizontal, or to draw a horizontal, which is our AB, representing U. Remember, U is what? 38 millimeters in millimeters, 38 millimeters. That's a horizontal line. From the second diagram, guys, we are starting with this one, the second diagram, all right? So let us just have our tools that we're gonna need. All right, so with this, just gonna construct, all right, let me just draw something like this here, and also it must be a broken line for the other constructions, but we're gonna do the proper construction later on. So what I need is what? 38 millimeters or 3,8 centimeters. So that's from 0 here to 3,8. 3,8 just before 3,9 here. 3,8, approximately somewhere there, like this. So that's the line AB from A to B of the second diagram. We are on the second row of the second diagram. All right. We have got that one. So that's our U, which is what? 38 millimeters. So what we can see is that we have VR4, this one, from B to D, and also the angle, because remember, we have got what? Calculated that VR4. So VR4 is at what? This one, VR4, is at angle phi 2. That is at angle phi 2. This one at angle phi 2, which is 30 degrees. All right, sorry. I need this one. I'm talking about VR4 at this angle. So that is what you're going to do. So you're simply going to draw a line from what? From, because we need VR4. We need this one, VR4. So we draw from B to D. All right? That's from what? From B. VR4, which is what? 45 millimeters at angle phi 2, which is 30 degrees, as we stated here. So that's what you're going to simply need. At what? At or from point B. So we are going to measure from point B. So this is it. All right, from point B. All right, let us place this one at as it is like this. At what? At point B. This is our point B like this, as you can see. All right, so what we need is 30 degrees this side. Remember, it must be like facing this side. All right, so from here 0, 10, 20, 30, which is here, you just mark. All right, so you just mark 30. All right, sorry guys, I just need to mark here. So this is it. Let's hope it's clear, this one. This is my 30 here. So I'm going to join from what? From B, passing through that point, 45 millimeters, which is 4,5 what? Centimeters. That line is representing what? VR4. That is the way that we can simply have direct like that. All right, so let's try and see on our joining here, on joining this. That's gonna be from B, okay, like this, passing through that point that we indicated there from point B, 45 millimeters. So as you are drawing the line, measure 45 millimeters in between up to here. 4,5 centimeters up to here. This is 4,5. So that is where it was going to be along the what? The 45 degrees. But 4,5 ends here, 4,5 centimeters, which is what? 45 millimeters. So that's going to be at what? At point D. So we have the point D from that. Okay, so that is it, our 45 degrees here. So we have got the point D from that information. So what do you think we can do? Since we have got the point D, we can simply what? Join. All right, so this was our VR4, 45 millimeters, which was taken from angle, this angle, phi 2. Remember, this is the second diagram, so this is angle phi 2, which is 30 degrees, the exit of the moving blade of the second diagram. So what we can simply do, since we've got the point D and the point A, join and measure. So join A to what? A to D, which represents what? A to D, it represents V4, all right? Absolute velocity, that's our V4, and measure that. So you join and measure. So that's from A to D. All right, approximately something like this, A to D, and you measure it after joining A to D, you measure it, all right? So that was actually the concept behind or having this diagram that we are given, all right? So if we were to measure this, it was going to be this A to D, it was going to be 22. This is 2, 1, 2, 3, 2,3, 2,3 centimeters. So that's 23 what millimeters, right? So that's our V4, like I said. So this is our V4, which is all right, so that's our V4, approximately what? 23 millimeters, approximately 23 millimeters, like that, okay? So as we can see, today we are supposed to have what? This one, the flow velocity D to E, the flow velocity from D to E, that flow velocity. But as you can see, it's closer to this V4 is closer. So guys, do not worry about that. Our flow velocity is taken at 90 degrees from the point D at what? 90 degrees. You must take it exactly at what? At 90 degrees. So that broken line that I'm having here is now for the what? For the flow velocity, which is taken at what? 90 degrees. So that's our flow velocity for. And you measure it. So you measure that well, VF4, all right, which is actually this one, you're not, it was going to be exactly the same as what we had. Remember, we said here it is 22,5. So if you're going to measure, it was going to be exactly that in between, or you're going to say from point D, all right? You're going to do like this. From point D, I'm going to need another instrument. All right, I'm going to need this canvas, this one. So I'm avoiding this, but you have it, guys, so you can use this for marking uh, points, all right? So what you do is that you measure that, all right? Let's say this is and our line, it was 22,5, which is 2, something like 2,2 centimeters that you have, maybe 2,2. Then from point D, you construct an arc on the line, on that horizontal, you construct an arc. It was going to pass on that horizontal line that you're given. So that was to mark the point, what? The point E, from D to E on that flow velocity, the one that you are originally given. But like I said, there is no effect here, guys, because we can see that even from that, if you are going to take it perpendicular from the point D, it was going to give us the exact measurement that we given before. That's 22, what? 22,5. So that is to show you that what you're doing there is accurate. So it can be 23. Do not worry about that. It can be 23. This one can be 23,5. This one can be 23, 24. So do not worry about that. This one can be 22. If you check, maybe it can be approximately, according to a diagram, maybe it can be 22. Do not worry about that. Use the exact value that you already given, because this one you were already given. So even if it's going to give you something that is not exact but closer to that, you write this one because originally that is what you were given. All right, so do not worry about that. So that is it for this first part. All right, we have A, B, D, and remember we have got VR3. So what we can do to have this VR3, what is happening is that this BC, the part of our VR3, right, which is going to the point C. If you check the point D and the point C, for those flow velocities to be equal, they must be horizontally on the same horizontal line. So this is what you're going to do. You're going to construct a horizontal view or a horizontal line, which is our horizontal view from point D. From point what? D. So you must have a horizontal view from point D. So you must make sure that it is a horizontal line, guys, perpendicular to ED. It must be perpendicular to ED. So you draw that horizontal view. So this is our horizontal view from what? From point D. I want you to see the magic that is just going to be formed here if you follow these stages properly. So as I have got this horizontal view, I know that D and C, they lie on that, they are found on that horizontal view. So what I can simply do is to measure from B to C, to that horizontal line, VR3, this one. I have it already. So I simply have to construct that VR3 from what? From point B. 47 millimeters. So you measure, that is where you're going to take that compass, then you use it, all right? So you're going to, let me have it here. You're going to need this, all right? You measure this 47 millimeters, which is like this 4,7 centimeters. All right, from point B, like this, from point B, you construct an arc, you mark an arc on that horizontal view, like this, an arc. So it must be 47. All right. So here, let me just confirm with the ruler because these can just differ. So here I was just going to place here at B, then 47 millimeters, 47. Yes, it's somewhere there exactly. So you mark that arc. So you mark the arc on the horizontal view. So you know that automatically that's your point what? That's your point C. As I said, D and C will be on the same horizontal line. For these flow velocities to be equal, this must be same horizontal line. So as I know my point C, you see guys, it's just issue of joining here B and what? B and C. So you just need to join that B and C. We already have it, guys, on our horizontal line. You just need to join it. So that's another step that was to be taken. You join that B to C. All right. So this is what we have. Okay. So this D to C is the total wheel velocity that we have. B to C, this B to C is our VR3, remember? So that's our VR3, this one that we already measured it as 47. It was already measured, this one, 47 millimeters. So as you can see, guys, we're almost done. What we can simply do now is to join A to what? A to C. We measure all these properties that are remaining. We are done with our diagram. So the rest, it is just measuring and so forth. All right. So here we're just gonna join, but properly join, yes, just because of this ruler sometimes can just shift anyhow. So you join A to C. A to C represents what? A to C, that's our V3. So we have got A to C representing our V3. So that's our V3. You measure that. So measuring this, our V3 from this, it was going to give us approximately 82 millimeters. This one was going to be 82 millimeters. So you just need to finish up. All right. Again, here from C to this perpendicular line, you measure 22, 5, then you mark an arc, then join to that perpendicular, being perpendicular at 90 degrees. All right. So that is going to give you what? The flow velocity for this one here at 90 degrees, same as what we had before here. So that's our flow velocity 3. Remember, we are working from the second diagram, and that is the same as this one, 22.5 what millimeters as before. So this one is just joining then, right? There's no need for you to measure anything because originally you were given, and it is at what? 90 degrees. So what is left from what? From C to D, remember we've been talking about this from C to what? From C to D, representing what? The total wheel velocity for the second what? For the second diagram. So you measure also that one, the total wheel velocity for the second diagram, which was going to be approximately 80 millimeters. All right. So that's it. We are done on the diagram with the information that we're given. The rest simply measure is they say they want all measurements. So the angles also this one, the inlet to this blade here, this is our theta, angle theta 2. You measure it for the second diagram. That's our theta 2. You measure it. It was going to be approximately 28, 29 degrees. You measure properly. All right. Use your protractor, measure. The same here. These ones, guys, you know them. Measure this one again, this angle alpha 2, which was gonna be approximately 16 degrees, and the angle beta 2, it will be this part here. It's not exactly at 90, it's not 90, it's approximately closer to 90, that angle beta 2, this one. That's our angle beta 2, which is approximately 88 or 89 degrees, closer, very close to 90 degrees, but it's not 90 degrees. This is the one that is at 90, the one at E, from E to D for the flow velocity. It is the one that is exactly at what? At 90 degrees. So that's the second diagram. We are done on the second diagram. So with the second diagram now, it was going to be easier for you to have the first diagram because some properties can be taken from the second diagram going to the first diagram. So this is what you're going to do. We started with the second diagram. So what we need is to have what? The first diagram, this one. So this is what you're simply going to need, all right? So that's it, guys. If you can work out this, you do not have problems. Okay, let me just try erase this. I just hope I'm gonna win. These ones, we used them. We're not gonna need these. We used them on our second diagram, all right? This is the sketch of the first diagram, remember? So I'm just going to put it somewhere here. All right. So we need to take from the second diagram back to the first diagram. And what we have on our first diagram is this angle beta 1, this one here, which we are given as 35 degrees. The condition of the flow velocities, we know this one, but we are not given, we just know it. So we are limited so much. But if you can consider, we can see that from the second diagram, we have the value of V3. Why are we concentrated on this? Because it helps us to obtain the value of V2 on the first diagram from the coefficient of friction. Remember, V3 is equal to K V2. So find what? V2. Find this V2 so that it's gonna help us somehow to construct that diagram. So divide by k. Our V2 is gonna be V3 over K, where our V3, we calculated this, we measured this, it was 82 millimeters. 82 millimeters divided by the coefficient of friction, which is what? 0.96. So that was gonna approximate to 85 millimeters. So we have V2 as well. In this case, we've got V2, 85 millimeters. So let's try to work out with what we have, because V2, the advantage of V2 is that it is or lies on what? On AD. That's where we got V2 on AD, where beta is. It's like this. This is our beta 1 and this is our V2. So from A, we can have our angle beta 2 and V2. So that will be easier. And the diagram is complete. Once you've got that, guys, the diagram is complete. So let's construct from the second diagram. You are going to take, all right, so you're going to need this one up, all right, from A here, but do not change this. So let me just use this. Let me use a ruler so that I'm gonna have an exact diagram. All right. So from A, we're gonna need to construct what? We need the velocity. Remember that one. So you take this one up. Is it enough? All right. Let me just erase this a little bit. I think it's gonna be enough, guys. If anything happens, you will adjust from there. But as for me, I won't be able to adjust, guys. We'll see. Let me see how it is going to be. So that is it here from what? From point A, then also from what? From point B, going up. You're now going up, guys. You're going up, right? Something like this. Okay. Something like this. So we are focused on the diagram that is on top. So this one below, what we just need is A to B, which is representing our U. So this is obviously the one that we have created from these lines. And remember, it was 38 millimeters from A to B. So this is no longer a sketch, it's now an exact diagram, guys. All right, so let's see. I'm just gonna have this one like this. Okay. Then join that one from here to here, the 3,8. I need to join it properly like this. So that's my what? That's my AB. I'm on the first diagram now. We are on the first diagram, remember? Okay. So these dotted lines, we need them like that. So this is what we have. We have constructed, or we have got the U, which is what? 38 millimeters automatically from the second diagram that we had. It gives us that U on the first diagram. So this is what I was trying to say. From point A, from this point A, this one, we are going to draw or to construct this angle beta 1 that we are given, the 35 degrees, at what? At V2, V2 and beta 1. Beta 1, V2, they are on the same. So as we are constructing this angle beta 1, at 35 degrees, we are having the line what? V2. So that is what you're going to see to do. So we're gonna construct this stage, this one. From what? From point A. So from A, measure 35 degrees going out, going this side. All right? From A, measure 35 degrees. All right? From this point A, you're going to place it like this. Then 35 somewhere here. Okay. That's somewhere here. That's where we've got our 35. So from point A, that's where we've got our 35 degrees. Okay. So let me just do this 180 minus 35. So let me just do this 215. So this is our 35 degrees, this one. From what? From A, like this. So you construct it, knowing that whilst you are constructing what? V2, 85 millimeters. So measure as well as you are constructing that, measure that what? 85 millimeters. So 85, that's 85, 80. 8,5 somewhere here. So this is somewhere here at what? 8,5. So that is what? A to D. Remember V2. This one, V2 lies on what? AD. So the point automatically that we have given here or that we have produced is what? Is point D automatically. So this is what we had from what? The angle beta 1, this one. All right, that was our angle beta 1, which is 35 degrees. This is where we are. Okay, so what can we do? What can we do this time? This is our V2, 85 millimeters. Guys, once you are at this stage, you are done, guys. I want you to see something from what we have. If we are to consider properly, remember you're on the first diagram. We have this point D. What is it that we can see from the first diagram? BD can be formed. You just need to join B to D. Direct like that. You just need to join. So join B to D. Like this. You join B to D. And what? And measure that B to D. Where B to D represents VR2. So you have got VR2 automatically. All right. So here, guys, let me just, okay, sorry for that. I just need to write my V2 here. Our V2, it was what? 85 millimeters. So this is our VR2. So you measure it from B to D. That was going to be approximately 119 millimeters. So you measure that one, all right? This one, B to D, you measure it, okay? Using your ruler. So that is it. And we know about the flow velocities. So what we can simply do here is what? From D, draw a perpendicular to the horizontal at 90 degrees. It must be at 90 degrees perpendicular from what? From point D. That's the flow velocity that you have produced from that point what? From that point D. And you measure it. It is at 90 degrees. That's the flow velocity 2 at the exit here, which is what? 49 millimeters approximately. 49 millimeters. You measure that 4,9 centimeters. Remember the concept that we are on the first diagram, sorry, here, so that VF1 is equal to VF2 for us not for the no axial thrust condition. VF1 is equal to VF2. So we are going to consider the same concept as before, the horizontal view from D to C. You construct the horizontal view from D going to C. The horizontal view, it must be perpendicular, direct at what? 90 degrees to this line. It must be perpendicular to that horizontal line. So you construct it at what? 90 degrees from what? From D to C. From D to C. So we're just gonna need something like this. All right. So that is on this horizontal line. All right, let's extend it. Let's try to extend it like that. So we understand or we know that from this horizontal line that we have from B to C, The line or the point C, actually the point, not the line, but the point C lies somewhere on this horizontal view. So how can we find that point C, this one? How can we find that point C? All right, that is the question. How can we find the point C here? All right, C is or can be found if we have got BC. BC represents what? From B to C, we have VR1. We have what? VR1. From B going to C, that's VR1. We have VR2. So find that VR1. You're done. So you're going to simply need to obtain BC from what? VR1. So find VR1 from VR2. We're done. So guys, let me just erase this. We already saw this. So that's from our first diagram. So VR2, remember, is equal to K VR1. So to find VR1 is going to be VR2 over K. So that's it. VR2, we have it here, 119 millimeters divided by K. The constant K was 0.96. Remember, it was 0.96. So since we are the ones who are calculating this, let us approximate to the nearest whole number, So that's our VR1 was going to be approximately 124 millimeters. All right. So we have VR1, 124 what? Millimeters. So with that, what you're going to do is to take your compass just like before. Remember this, all right? You take this one, all right? You take this one, you measure 20.4, which is 12.4. Now this one, as you can see, it opens but does not have that 12.4. So for me, it cannot work. But let's say we have opened that. You're going to construct from point B to that part where you have got what? Where you've got the horizontal view. All right, so that is what you're going to do. But here I can simply use a ruler from point B. From point B, I open up. All right, from point B, I'll be focusing on what? I'll be focusing on 124 millimeters. 124, guys. These are centimeters. So 124 is what? 12.4. 12.4 centimeters. 12.4 centimeters. So I'm just going to focus on what? 12.4 centimeters, where it is going to meet this horizontal line, but it must be at what? 12.4, somewhere here. All right, I have to shift 12.4. Yes, something like this. So that is using the ruler now, but you're supposed to use what? The compass, like I said. Then you join. Let's say you marked an arc using your compass. Then you simply join now using what? The ruler. So that was how you're supposed to do it. But now, as we saw, guys, it was going to be limited according to what I'm using here. So that is it, guys, according to what you have or what you are working with. All right. So that's our 12.4 watt centimeters or 124 millimeters, representing our VR1. So that's 124 millimeters, which is taken from what? From B to C. So that's our point C here. From B to C. From B to C, VR1. Just like that. So we are done. As you can see, guys, we are almost done. What you simply need is to complete the diagram. All right, from A to C, we simply need to join this one, join A to C, representing what? Our V1. So you join and also measure A to C. So A to C of the first diagram, that's our V1. So we have got V1 there. So you measure that V1, it was going to be approximately 159 millimeters, 15.9 centimeters, 159 millimeters. So the rest is just finishing up the diagram. as we can see from what we have here, and also the flow velocity at the end from point C, we know that it's 49 millimeters. Remember, it's the same. So from C, measure 49, construct an arc on that horizontal line, then you simply join to the horizontal line. It is going to be perpendicular. That line that you're going to have, guys, will be what? Perpendicular at 90 degrees. Or you can simply take it from point C at 90 degrees. Automatically, what you are going to have there, it is going to give us the same measurement as what? Our VF2. That is another way to see that what you are doing is correct. So your VF1 direct as your VF2, 49 what? Millimeters. So that's it. And this one is at 90 degrees. So like I said, we are done. All the rest, we just have to measure. This one, the flow velocity, I mean the wheel velocity, this one from D to C, the total wheel velocity from D to C, measure as well. All right. For the first diagram, that was going to be approximately 222 millimeters, all right, for that first diagram. And what is remaining, the angles, all right, here on the blade, the inlet to the blade, our theta 1, you measure approximately, it was going to be 23 degrees. And this angle phi 1, the exit to the blade, the exit from that blade, approximately 25 degrees. The nozzle angle here, our angle phi 1, all right, so it's going to be approximately 18 degrees, something like that. So you just need to measure up everything that is left. All right, if there's anything that I left, guys, just update or refer it on the comment section, and the values that you're also obtaining, right? But that was it. This is our first diagram, as we can see, taken from what? From the second diagram. We needed V3, and using that V3, we obtained V2 from the what? Coefficient of friction. So that alone enabled us to finish this diagram. So guys, with the construction mindset, you can finish this diagram. All right, you just need to be very, very focused on what you are working with or what you are dealing with on your constructions. Yes, calculation. I'm not against the calculations. You can do adjustments in terms of calculations, all right, from what you're given to find what is missing. But sometimes another information might be completely missing. Then you need to calculate with the idea of what the diagrams will look like to obtain other values. Then you use it now to draw your diagrams. It is not a problem if you can do that, but where you are limited, where you can work from the second diagram, do so. Just work from the second diagram going to the what? To the first diagram. Still, you are going to have exactly one and the same thing. All right. So thereafter, they wanted us to have these on 5.21, 5.2, determine from the velocity diagrams, all right, 5.2.1, the velocity of steam entering the fixed blades in meters per second. Entering what? The fixed blades. Remember, this is the part of the fixed blades. So what enters is the exit from here. This is the one that will enter. So that's our V2. Just like the angle beta 1 is entering the fixed blade, but there is the exit. So V2 is the exit from what we have on the first diagram, but it means it will be the entrance of what? Of here on the fixed blade. So that's V2 that they're referring to. So our V2, we already have that 85 what? Millimeters. Then use the scale, multiply by the scale. So that's going to be simply 85 times 4. Remember, 1 millimeter to what? 4 meters per second. They want it in meters per second. So that was going to be 340 meters per second. Use what you obtained, guys, all right? 5.2.2, the velocity of steam leaving the fixed blades in meters per second, leaving what? The fixed blades. So this is part of our fixed blades. So leaving, that's our V3. So V2 enters, then V3 exits. So V3 is what? 82 millimeters. So that's 82 times 4, which is 328 meters per second, all right? So that's our V3. The inlet angle, the inlet angle of the first row of moving blades, the first row, the first diagram. Here, the moving blades at point B, the inlet. So that's our angle at theta 1. So 23 degrees, all right? Theta 1, 23 degrees. The exit on 5.2.4, the exit angle of the first row of moving blades. So you're still on the moving blades of the first row, but the exit is what? Phi, angle phi 1. This angle phi 1, 25 degrees. All right, so that's angle phi 1, which is what? 25 degrees. Then the inlet angle of the second row of moving blades, the inlet angle, second row. So this is the second row. The inlet to the moving blades is what? Theta 2, 29 degrees. So that's angle theta 2. So that's our angle theta 2, which was 29 degrees. The nozzle angle from the first diagram, the nozzle angle here is what? Angle phi 1, 18 degrees. That's our nozzle angle, phi 1, 18 degrees. That is it. And 5.27, the outlet angle of what? Of the fixed blades. As we consider the fixed blades, the outlet angle for the fixed blades, the outlet angle will be this angle alpha, alpha 2. So that's alpha 2, which is 16 degrees, approximately like that. All right, then 5.28, the power developed in the turbine in kilojoules per kilogram steam, in kilojoules per kilogram steam. So once you're given this power, mass, but that is not to be considered. Then we're going to need the total of the wheel velocities that we consider for both diagrams. So this must be in meters per second. Also, this one, this U here must be in meters per second. And mass per kilogram, you're not given the mass, so you take it as 1 kilogram, so that will be kilogram steam per kilogram of what? Steam. So that's simply take the value of U. We have our U in what? Meters per second as given before. Our U is what? Before we converted, that was 38 millimeters, but before it was 152. Yeah, before we converted 152. So they just use that one in meters per second, 152 times. Here we have got these wheel velocities given in millimeters from our diagrams here. So what we are going to do is to convert them to meters per second. So here they are given in millimeters. Take them as they are. 222 for the first one, and the second one 80. All right, so that was 222 plus what? The second one is 80, like this. Then whatever that you have, multiply by the scale. 1 millimeter representing what? 4 meters per second. So you must multiply by the scale to convert everything to meters per second. All right. So that's per a kilogram of what? Per a kilogram of steam. That is what you're going to have. All right, so simple like that, we are going to obtain something approximately 183,616 joules per kilogram of steam, which you can convert to joules as we are given, divide by 1,000, 183,616. So it's going to be kilojoules per what? Kilojoules per kilogram of what? Of steam. If you want, you can write per kilogram of what? Of steam. So that is basically what you are going to have at the end. So you see, guys, after this, after the diagram, the rest is just taking from the diagram. So as long you understand your diagrams here, as long you understand this information, you are done. So remember all this with what we had before about the first diagram and the second diagram. What you do not understand, other calculations and additionals that you need from your N5 power machines. Do revise all those basics so that you properly understand what you are working with, exactly what you are working with. So that is it. That is how these questions might be given, as it's all about revision. So let's communicate where we do not understand so that we can work out those typical questions separately. But for now, that is it till we meet again.